You're squinting at this screen right now, don't lie. You've been squinting at screens for years. Maybe you wear glasses, maybe you wear contacts, maybe you've considered lasering your eyeballs, which, if you think about it for too long, is genuinely insane as a concept we've all just casually accepted. Here's the thing, for 99% of human history, nobody needed any of that. No glasses, no contacts, no lasers, no squinting. Ancient humans with perfect vision hunting prey at a distance, tracking stars with naked eyes, reading the landscape like a map that never required a zoom function. And then something happened. Within a single generation in some East Asian populations, myopia rates went from under 20% to over 80%. Not over centuries, not over millennia, one generation. The question is not why some people need glasses. The question is why almost everyone suddenly does. And the answer reaches back further than anyone expected. Part 1. The Eyes That Built Civilization. The year is 1997. You are in a research laboratory at the University of Sydney, Australia. An optometrist named Brian Holden is staring at a dataset that doesn't make sense. He has been tracking myopia rates across Asia for a decade. The numbers climbing in his charts are not the product of gradual generational drift. They are vertical. He checks the data again. In 1950, myopia affected roughly 10 to 20% of the Chinese population. By 1997, that number in urban areas has crossed 70%. In some cohorts of university students, it is approaching 90%. Holden leans back. This is not genetics. Human DNA does not rewrite itself in 50 years. Something in the environment has changed. Something is doing this to human eyes. Here's where it gets strange. The fossil record shows almost no evidence of myopia in ancient populations. Skeletal analysis of eye socket geometry in pre-agricultural human remains shows orbital structures consistent with normal vision. Studies published by anthropologist John Hawks at the University of Wisconsin found that the physical architecture of ancient human skulls suggests visual systems optimized for exactly the kind of environment ancient humans lived in: open landscapes, distant horizons, moving prey, starlit skies. Ancient human eyes were not just functional, they were calibrated for a world that no longer exists. Part 2, What Ancient Eyes Were Built for the Year, is 2018. You are in the Kalahari Desert in Botswana. A researcher named David Lewis Williams from the University of the Witwatersrand is documenting something the Sand Bushmen do every morning without thinking about it. They wake before sunrise, they walk outside, and they look at the horizon, not at a phone, not at a book. Not at a wall 2 feet from their face. At the horizon, miles of distance, sky meeting earth, light changing by the second as the sun rises, Lewis Williams asks one of the elder hunters how far he can see. The answer, when measured later against landmarks, is approximately 6 miles with the naked eye. 6 miles. The average myopic adult in a modern city cannot read a road sign at 30 feet without correction. Here's where it gets strange. Researchers studying the visual systems of populations that still live traditional outdoor lives consistently find dramatically lower rates of myopia. A 2012 study published in The Lancet analyzed 4,000 children across Sydney, Australia, and found that time spent outdoors was the single strongest protective factor against myopia development. Not screen time, not reading, not genetics, outdoor time. The specific mechanism involves light. Bright outdoor light, at intensities of 10,000 lux and above, triggers the release of dopamine in the retina. Retinal dopamine regulates eye growth. Specifically, it prevents the eyeball from elongating too rapidly during childhood development. An elongated eyeball is a myopic eyeball. The focal point of light falls in front of the retina instead of on it. The world goes blurry. Ancient children spent their entire childhoods outside every single day, from birth until the day they died. Their retinas were flooded with dopamine. Their eyeballs grew at exactly the rate they were supposed to, and nobody needed glasses, because of course they didn't. They were living in the environment their eyes were designed for. The idea that an ancient human would spend 12 hours a day staring at a wall 2 feet away would have been as alien as asking them to check their inbox. But the dopamine explanation is only part of the story. The next part involves something nobody saw coming. Part 3, The Agricultural Betrayal. The year is 2015. You are in a genetics laboratory at University College London. A researcher named Chris Hammond has just published a study in Nature Genetics that has identified 24 genetic variants associated with myopia. This should be the answer. It is not. Here's where it gets strange. Those 24 genetic variants are not new. They are ancient. They appear in human populations going back tens of thousands of years. The genes that predispose to myopia have been present in the human genome for longer than agriculture has existed. But myopia rates in pre-agricultural populations were vanishingly low. The same genes, different outcome. Hammond sits with that for a long time, because what it means is that the genes are not the cause. The genes are a loaded gun. The environment is the trigger. And the environment changed approximately 10,000 years ago. Agriculture. The moment humans stopped moving through open landscapes and started sitting inside structures, staring at close work, grinding grain, weaving, reading clay tablets, counting seeds, the trigger was pulled. Not immediately. The process was slow at first, a few percent here, a few percent there, but by the time the Industrial Revolution arrived and put children inside factories and then schools and then offices, the rates began climbing in the way Holden would document in his laboratory in 1997. The agricultural revolution didn't just change what humans ate, it changed what human eyes looked at. And the eyes, ancient and inflexible as evolution always is, never caught up. But here's what nobody in Hammond's laboratory that day was prepared for. The discovery that was about to come out of a school in China. Part 4. The experiment that should have changed everything. The year is 2009. You are in Guangzhou, China. A research team led by Dr. Mingguang He at Sun Yat-sen University is running an experiment so simple it seems almost insulting. They take a group of school children. They send them outside for an extra 40 minutes per day. That's it. No special equipment, no medical intervention, no curriculum change, no drugs, no surgery. 40 minutes outside. 3 years later, the results are published in JAMA Ophthalmology. The children who went outside for an extra 40 minutes per day had a 23% lower rate of myopia development than the control group. 23% from 40 minutes of outdoor time. The researchers run the numbers forward. They calculate that if Chinese children spent the amount of time outside that their ancestors spent, current myopia projections for East Asia would drop dramatically. The intervention is free. It requires no technology. It is, in the most literal possible sense, as old as the human species, and virtually no school system on Earth has implemented it at scale. The door is right there. Nobody is walking through it. Closing look up from this screen for a moment. Find the furthest point you can see from wherever you are. A window, a skyline, a tree line, anything beyond arm's reach. Your eyes just did something they were built to do. Something your ancestors did every waking hour of every day for 300,000 years. They focused at distance, they let the light in, they did the thing retinal dopamine was waiting for. It took you 2 seconds. Ancient humans did it their entire lives, and they saw perfectly. The mystery is not why ancient humans had good vision. The mystery is why we know exactly what changed, exactly what the eyes need, exactly how to protect the vision of every child alive today, and we are largely choosing not to act on it. Someone figured this out in a school in Guangzhou in 2009. The evidence has been replicated. The mechanism is understood, the intervention costs nothing, and the myopia epidemic is still accelerating. Some questions answer themselves. The answer just turns out to be more uncomfortable than the question.